right? In kinetic theory of gases, the 18th question is, there are two columns are given, match these two columns. Okay, what is the first given? Root mean square speed of a gas molecule, pressure exerted by ideal gas, average kinetic energy of a molecule, total internal energy of 1 mole of a diatomic gas. Okay, this is given. Okay, now it may be done based on previous knowledge. What is that? According to law of equipartition of energy. Actually, this is done based on that concept. Okay, but according to given things, second one is what is that? Pressure exerted by ideal gas. Okay, from kinetic theory of gases, okay, you have to derive pressure exerted by ideal gas. What is that? Pressure exerted by ideal gas, okay, is equal to 1 by 3 mn v bar square. Here v bar is the root mean square velocity or root mean square speed. So this is correct. Okay, based on this main postulate we should arrive, okay, from kinetic theory of gases, we would like to derive the expression for root mean square speed of a gas molecule. Okay, so here n is equal to what? Here in this equation n is equal to number of moles per unit volume of sample. What is that? Number of moles, okay, number of moles per unit volume of a given sample. Therefore, that which is equal to what? Which is equal to n by v. So I would like to replace this n by v in this place of this pressure exerted by the gas equation. Therefore, pressure P is equal to 1 by 3 m into small n is equal to what? Capital N by v into v bar square. So this v is brought into this side. This equation is slightly modified as PV is equal to 1 by 3 m into n into v bar square. Okay. Okay, but you know this m into n is equal to what? Number of molecules are present in given gas and mass of each molecule. This is replaced by total m, total mass of the gas. Therefore, further modified this pressure equation, PV is equal to 1 by 3 capital M into V bar square. Capital M into what? V bar square. So this is a equation 1. Okay. Next one, from ideal gas equation. What is that? From ideal gas equation. What is that ideal gas equation? PV is equal to what? N into R into T. Here N is equal to what? Number of moles present in given mass of gas, isn't it? So it may be written as mass, total mass of the given gas by molecular weight. Here small n is equal to what? M by m naught. Total mass of the gas by molecular weight of the given sample. That implies this equation is modified as PV is equal to capital M by m naught into R into T, isn't it? Now this is a equation 2. So from equation 1 and 2, from equations 1 and 2, you may write what? PV is equal to what? 1/3 m capital M, 1/3 capital M into V bar square is equal to m by m naught into R into T. On both sides, m is cancelled. This V brought into this side. This 3 is what? Brought into this side. So what happened? V bar square is equal to 3 RT by m naught. Isn't it? That implies V bar is equal to under root 3 RT by m naught. This is the expression for root mean square speed of gas molecule. So first one, second one, both are same, isn't it? Right. Right. The third one, average kinetic energy of a molecule. This average kinetic energy of a molecule can be obtained from law of equipartition of energy. That means from law of equipartition of energy. Law of equipartition of energy. What it tells us? the total number of possible independent ways. What is it? The total number of possible independent ways in which the particle of a system can take up energy is called degree of freedom of that system. For example, a molecule is supposed to be move in a space. How you could locate that particle move in a space by using three-dimensional Cartesian coordinate system, so that a particle move, that means translates from one point to another place. Okay, you should require three axes. So these three axes are called degree of freedom, so that a molecule free to move in a space has three translational degree of freedom. Similarly, that particle may be vibrate or that particle may be rotate, isn't it? So you want to specify a rotating body, you should also require, what is that? Two coordinates are required. Why? Because in translation there are three degree of freedom is required, three axes are required. But when a particle is rotate, that means its rotation must be in any two dimension, that means in a plane, isn't it? So when a particle move in xy plane, that is parallel to z axis, when a particle move in yz plane, that is parallel to x axis, when a particle move in xz plane, parallel to y axis, so that when a particle rotate, it having two rotational degree of freedom, isn't it? Like that. Okay, here what is again average kinetic energy of a molecule? So according to law of equipartition of energy, when a particle is rotate, okay, or when a particle is move, okay, in a space, we required three, okay, coordinate axes are required. Okay, but when a particle move, it having some kinetic energy. According to kinetic theory of gases, what is you have to know? When a particle is move, that means in the state of motion, it possesses some kinetic energy, isn't it? So what is the measure of internal energy of a molecule? It is nothing but temperature. So half mv square is obtained as of kBT. Here kBT is nothing but what? Boltzmann constant, and it is the absolute temperature. So that when a particle, okay, while in translatory and rotational motion, or that means degree of freedom, okay, each molecule, okay, contributes this amount of energy, So average kinetic energy, for example, when you take a monoatomic gas, that monoatomic gas, okay, having 3 degree of freedom, because that particle is free to move. So if free to move means what? In space it is move in three-dimensionally. So that average kinetic energy of a molecule, U is equal to 3 into 1 by 2 kBT. That implies U is equal to what? 3 by 2 kBT. So the total average kinetic internal energy of a molecule is nothing but 3 by 2 kBT. For monoatomic gas, total internal energy contributed by the all molecules is equal to what? 3 by 2 kBT, because monoatomic gas molecules have free to move, there is no restriction. So you want to specify its location in a space, you require 3 degrees of freedom. So 3 into each molecule contributes energy 1 by 2 kBT. So total energy for monoatomic gas is equal to what? 3 by 2 kBT. Now for diatomic gas, what is it for? Diatomic gas. Okay, this is contributes. What is this? Is contributes 5 into 1 by 2 kBT. That equal to what? 5 by 2 kBT. So this is the required energy. But according to previous knowledge, what is the diatomic gas molecule having n number of moles? So that the fourth one, what is the total internal energy of a 1 mole of diatomic gas molecule is nothing but what? 5 by 2 RT. That's it. So all are given correct. That means root mean square speed of a gas molecule is equal to root over 3 RT by m. Pressure exerted by ideal gas equal to 1 by 3 mn into V square. average kinetic energy of a gas molecule is equal to 3 by 2 kBT, and total internal energy of 1 mole of a diatomic gas is equal to what? 5 by 2 RT. Okay, so the given 4, 1 are correct.